Hello, my name is Georgios Mihail Makrakis, and I will present you our work, a quantitative approach and an open source tool for social impact assessment. This paper has been written in collaboration with Justin Walters and Amil Mirkoui from the University of Idaho. As an overview, first we are going to talk about the objectives and the motivation, and also some background information about this research area. Then we are going to move with the materials and methods, and more particularly, we are going to discuss the tool and the LCA methodology. And after that, we will show the case study that we conducted using the created tool. And in the end of the presentation, we are going to provide some conclusions and some future directions. So as for the objectives and motivations, we wanted to have a proper assessment of sustainability for various technologies that can assist the reduction of impact in natural resources in livable areas. Recently, a lot of attention has been paid to social sustainability, particularly after the year 2000. We for this work we use the life cycle assessment, or LCA for short, as the standard procedure in order to reduce the practitioner's bias and also to be consistent with the set of guidelines and requirements that are put out by regulatory bodies or organizations such as the United Nations. And last, an investigation of the set of the science and the creation of a tool that can be used for social impact assessment using the LCA phases was another motivator for this work. Some background information. We have investigated many papers, and we see that the sustainability assessment can be broken down either to one-dimensional aspects or two-dimensional aspects. The first one includes the environmental, economic, and social, while the latter includes the eco-environmental, socio-economic, and socio-environmental. And each one of them can be expressed in the corresponding units. For example, the eco-environmental and socio-economic use money units, while the social environmental can be expressed in environmental units. For the material and methods, we used quantitative methods due to their consistency and reliability in the impact assessment of procedures and metrics. We utilized the standard LCA structure from the ISO 14040, and we wanted to have a comprehensible method and results that can be used by both practitioners and students. So as for the LCA method and how that is connected to our created tool, here on the left, we have all the LCA phases. There are 4 phases in the lifecycle assessment method, and each one of them corresponds to a feature in our tool. So, for example, as we can see here, the phase 1 is about the goal and definition. So here the user can define the purpose of the tool and the goal of, the purpose of the assessment and the goal for the study. And also the users can select the objective. The objectives can be social, economic, or environmental. As for phase 2, the life cycle inventory, here is where we utilize our data. The users can either create databases or import databases, and for each data can be used by up to 2 processes. In phase 3, we have the lifecycle impact assessment, where a custom mathematical model was employed, and the social analysis method uses indicator values, and more particularly a score for each one of these indicator values is provided based on weighted values. And lastly, for phase 4, Here is the interpretation. So we wanted to visualize the results for better comprehension, and also we wanted to for the users to have the ability to export all the conducted study as a PDF for maybe later analysis or comparison in comparison to be used for comparison with other studies. Some more details about the proposed tool. First, it's free and open source, so anyone can use it and modify it or suggest changes. Also, we wanted to be accessible, so we use web-based technologies for that. So anyone with a web browser can use this tool. It's very simple and it focuses on the frequent use from scholars in both academia and industry. As we discussed in the previous slide, we have two database options. So the creation of the databases can be used either for internal or public release of the data. That depends on the objectives of the researchers. Maybe they want to share their data, or maybe the data can be used by only by their own group. And also, if the users have acquired or developed their own databases, they can import them to our tool and they can use them in their study. Also, the mathematical model that we integrated is very easy to understand, so the researchers can suggest modifications or even do their own changes to that. And lastly, the comparison of two processes can assist the demonstration of a proposed method, a new method, and how that gets compared to an established one or any other similar comparison. And lastly, we have the creation of PDFs that, based on the preliminary result out of users find interesting. So as for the case study demonstration that we have conducted, the tool is very adaptive to the objective selection. So each time we change the objective, the whole UI changes in order to reflect the appropriate changes. And all the fields are populated in correspondence to the objective. The users can add multiple records for each indicator, allowing them to import as many data as they want. And particularly in phase 4, the interpretation, we wanted to provide the capability to the users to either hide or show information based on their own preference or what they want to present in the end of the study. And we can see here also in the right figure that we included the data for this example study under the social objective, but we decided to use the create database option by not using the custom data, but acquiring the data from actual federal government agency databases. But this might argue that the import database is the best option, but this is the flexibility of this tool. So we carved out the particular data that we wanted to use, and we imported them into as a custom database. So that is one of the main flexibility aspects of this tool. As we conclude this presentation, we noticed that the SIA is a rapidly growing field. The social life cycle assessment needs continuous mathematical modeling, so we provide some references and some the current research reference from the current research that exists out there in our paper. And we would like to see in the future modular extensible tools that can be used for both of these three types of assessment: for the social life cycle assessment, the environmental one, and the life cycle costing. Integrated approaches also can assist decision makers by analyzing performance of processes and systems on particular areas that may need their attention. And as for some future investigation, we would like to improve or include other mathematical models for social impact analysis across various manufacturing facilities. And we would like to explore the social metrics, indicators, and domains that may provide identification and may provide information from specific industries or processes. So in the end, we would like to acknowledge the University of Idaho and the Idaho National Laboratory for their support and Mrs. Mesha Fry for her inputs. If you have any questions, please do not hesitate to reach out to our emails that you can find here on the bottom left of this slide. Thank you very much, and I hope that you will enjoy the rest of the conference.